Hello friends, today we are going to study about the consistency or inconsistency of system of linear equations. So a system of linear equations are consistent if it has at least one solution and inconsistent if it has no solution. Let the two linear equations be of the form a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. Now the conditions arises. If a1 upon a2 not equal to b1 upon b2, then the given system of linear equations will have unique solution. The two lines will intersect at a point. The system of linear equation is said to be consistent and the lines will look as this. They are going to meet at a point. Let this point be a dash and b dash. So this a dash and b dash is the solution. X value is a dash and y value is b dash. Now let us get the example from here. X plus 2y equals to 3, 4x plus 3y equals to 2. So we can see a is 1 and b is 4. a1 upon a2 is 1 by 4 and b1 upon b2 is 2 by 3. a1 upon a2 is not equal to b1 upon b2. So the given system of linear equation will have a unique solution, and the lines drawn by these equations will be intersecting lines. Second, if a1 upon a2 is equal to b1 upon b2, then the two cases arises here is a1 upon a2 equals to b1 upon b2 equals to c1 upon c2. Then the two given lines will have infinitely many solutions. The two lines are coincident, that is, they will lie on each other. The system of linear equation is said to be consistent and the lines will look as, you can see, the one bigger line and the one smaller line lies on the bigger line. Example, x plus 2y equals to 4 and 3x plus 6y equals to 12. So here you can say a1 upon a2 1 upon 3, b1 upon b2 2 by 6 is 1 by 3 and c1 upon c2 is 4 by, if you want you can bring it this side and you can say minus 4, and this if you bring this side it will become minus 12. So minus 4 upon minus 12 it will become 1 by 3 again. So the given system of linear equation will have infinitely many solutions. The second case is if a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2, then the given system of linear equations will have no solution. The two lines are parallel. The system of linear equation is said to be inconsistent and the lines will look as parallel lines. For example, x minus y equals 8, 3x minus 3y equals 16. Before solving the equation, you can bring 8 this on the left side only. So this becomes x minus y minus 8 equals to 0. And 3x minus 3y minus 16 equals to 0. In all the cases we bring c on the other side, that is on the left side. So here we can see a1 upon a2 is 1 upon 3, b1 upon b2 is also 1 by 3, c1 upon c2 is 1 by 2. So a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. So the given system of linear equations will give us no solution and the lines drawn will be parallel on the graph paper. How to solve the given linear equations graphically? We have two equations over here, x plus 2y equals to 3 and 4x plus 3y equals 2. So first make x an independent variable and y a dependent variable. That is, write the equation y in terms of x. So x plus 2y equals to 3 or 2y equals to 3 minus x and y equals to 3 minus x by 2. Here 4x equals to 3y, 4x plus 3y equals to 2, 3y equals to 2 minus 4x and y equals to 2 minus 4x by 3. Equation 1 and equation 2 are the required equations. You can see. From 1, put any random value of x, let it be 0, 1 or 2 or any other number to see if we get an integral value of y. When x equals to 0, we get y equals to 3 minus 0 by 2. 3 minus 0 by 2. It is not an integral number, it is a fraction. When x equals to 2, y equals to 3 minus 1 upon 2, that is 2 upon 2 equals to 1. this becomes an integral number. So we have come to know that the integral value of x equal to 1 will also give an integral value of y equals to 1. So putting x equals to 1 gives us an integral value of y. This is the first solution. Now put x equals to 3 but y and not 2. So in equation 1 we have seen y equals 3 minus x by 2. Now this number plays a very significant role over here. Look at the denominator value. It is 2. So we must either add 2 or subtract 2 from value of x equals to 1. We have got the solution for x equal to 1 as y equals to 1 as an integer. So we have to add now with x either plus 2 or we have to subtract either minus 2 in order to get the integral value of y. So when x equals to 3, y becomes 3 minus 3 upon 2 equals to 0, and when x equals to 5 we get y equals to 3 minus 5 by 2 equals to minus 1, and when x equals to minus 1 we get 3 minus minus 1 upon 2 equals to 4 by 2 equals to 2. So find at least 3 values in order to join them to get a straight line. So we need at least 3 points in order to get the straight line for the given equation. For second equation, y equals 3 minus 4x, 2 minus 4x by 3. Choose a value of x at random. We get fractional value of for x equals to 0 and 1. But for x equals to 2, we get y equals to 2 minus 4 into 2 by 3, that is minus 2. Integral y. Now we look at the denominator again, it is 3. So now we have to add 3 to the first solution for x. We have seen here ki x equal to 2 we get y equals to minus 2. So I am adding over here 3. So we get 5. Again add 3 to 5 we will get 8. You can also subtract from 2 the number 3. So 2 minus 3 you get minus 1. On putting these values, x equals to 2 plus 3 equals to 5. 5 plus 3 equals to 8. 2 minus 3 equals to minus 1. We note that the denominator in the equation above is 3. So we need to add or subtract from the value of x equal to 2 in order to get the integral value of y. So on putting these values, we get x equals to 5, then y equals to minus 6, x equals to 8, then y equals to minus 10, x equals to minus 1, y equals to 2. Looking at the graph, we can see that both lines meet at point 1, 2. Let's see the graph. So these are the two graphs which I have drawn over here. X plus 2y equals to 3. This is the line, and I have already marked all those points which we got in the previous paper. That is, these are the points 1, 1, 3, 0, 5 minus 1, minus 1 and 2. We can see here 1, 1. This is 1, 1. This is 3, 0. This is 5 comma minus 1. This is minus 1 comma 2. For the second line 4x plus 3y equals to 2, we get the points as 2 minus 2. So 2 minus 2 is this. 5 minus 6. 8 minus 10. And then minus 1 comma 2. On extending the lines, we can see that the both lines meet at point minus 1 comma 0. So the value of x is equal to minus 1 and the value of y equals to 2 are the solutions to the given system of linear equations x plus 2y equal to 3 and 4x plus 3y equals to 2. The solution to the given system of linear equation is x equals to 1 and y equals to x equals to minus 1 and y equals to 2. Now let us verify from the given equation x plus 2y equals to 3, x plus 2y minus 3 equals to 0, or 4x plus 3y equal to 2, 4x plus 3y minus 2 equals to 0. Here a1 is 1, b1 is 2, c1 is minus 3, a2 is 4, b2 is 3 and c2 is minus 2. We get a1 upon a2 equals to 1 by 4 and b1 upon b2 equals to 2 by 3. Therefore, a1 upon a2 is not equal to b1 upon b2. So consistent unique solution, the lines are intersecting and the graph will look like intersecting lines, hence verified. So we have seen in this paper that it is a unique solution and the lines are intersecting. Thank you.